Hello there. So I've been playing around with this function tree thingy that, yeah, I think I've been talking to lots of different people about it. And the idea is that we have extracted the signals implementation from Cerebral, but instead of calling it like signals, I've been trying to kind of like redefine it to make it a more generic kind of tool. And what signals really are is just a function that runs multiple functions. And these functions are defined in a tree, so therefore function tree. Um, and of course, we need a debugger for this. So I just implemented something that works. And I just copied the Cerebral debugger, so you see some leftovers from Cerebral here. But it really is its own thing. So we have an application here with a button, but there isn't really much happening. So the way you typically will use function tree is that you will create a kind of like your application specific function tree, because by default it doesn't really do much. You can call it and you can kind of like call functions through the function tree, and you can give it an input, and you can give it what we call an output in Cerebral. It has changed here a little bit. I'll get into that. But you can't really do anything else. So the idea behind function tree is that you can do whatever. Like you can hook it up to Baobab directly, you can hook it up to Redux, MobX, MongoDB, it doesn't matter. You can hook it up to anything. So what you would typically do is define your function tree. And when you create a function tree, it takes two arguments. The first argument is the list of providers. And this is actually how Cerebral works. It actually creates, for every action that runs, there's like, it runs through all the providers and creates the input, the output, the state, the services, and everything. And you have the same concept here. And then the second argument is the actual tree, like the signal. But a good way to, since the first argument is the context providers, we can actually just function tree bind. So we just bind the first argument, and that will give us yeah, so we just bind the first argument, which is all the context providers we want to use. So I can insert a debugger provider here now, and if I save this now, I think actually if I refresh now, no, I don't see it yet. No. Anyways, now I have my own. Oh yeah, I have to run it first, I think. Anyways, I have to create my function tree function, and I can do that by importing app function tree from app function tree. And what I want to do is just create do something, and that will be an app function tree. We can also put new in front of this if you like to do that. And let's just insert a test here. Okay. So let's put an on click here and then say that you should run tests. Oh, sorry, not test, but do something like that. And let's run this and see what happens. Yeah, so now that I have defined my first function tree, the debugger actually fires up. And if I click this now, oh yeah, there because in Cerebral we have names on signals, and what we can do here is say do something. So we still want to name these functions, and this is only for debugging purposes, but anyways we can name them. And let's see if I refresh again. There we have it. Okay, so I clicked it and the debugger picked it up. So what I can do here now, I can pass it, for example, foobar, and we'll refresh, and we test again. And now we can see that I got foobar as an input here. Okay, so let us move this test up here just to make it a bit nicer. Let's call it func A. And we want to run func A, and then we want to run func B. So let's make a copy and call func B. And then if I refresh and test again, we can see that I have func A and func B. And it's the same payload on both of them. So what has changed now is that instead of using this output, we either have something called a result instead, and we actually return it. And this makes things a bit more natural, like you return something when you want to move on, and it actually also allows us to return promises. So we don't need this async property anymore. We're kind of like trying to clean that up. So if I first now start by returning a result, foo2 bar2, hope this works. I haven't tested any of this. And yeah, so on func A, we have that input, but then we got foo2 and bar2 as well. Now, so if I rather return a promise here, new promise, and then we get resolve, and after a couple of seconds here, we are going to resolve the result. And let's see if it moves after 2 seconds instead. So I refresh, I click it, and then after 2 seconds, you saw it was transparent, and then it suddenly appeared. So I click again, it's transparent. Now it's done running, and it shows the payload. So this is kind of cool. Yes. So let's do something else here. We can say that we should move into a success here instead with func B. And the way this works now is that we actually don't have to even set the outputs on the function anymore, because after Alexis refactor, it analyzes all the outputs and makes it available when the context is created. So now it just understands that this result won't work anymore, because now it expects there's an object here. So we have to say result success instead. So if we refresh and test again, we see that function A has a success and an error, and after 2 seconds it updated this one. So this is pretty cool, and as I said, this is completely generic. We can do whatever we want there. So let's do that. We're going to create a new context provider, and let's imagine this is a dispatch provider for Redux, and we get the context here. Yeah, we don't really need to handle anything more than that. And here we would, of course, get access to the store, and we would put like dispatch, and let's see, dispatch, and for example, get state. Get state on the context. So that would be like maybe more like the Redux provider. Now, the thing is that now this will be available on the context. So when I do, for example, we have result here. Maybe we can do it here instead. On func B, I could say like dispatch, for example, and that will just work. But the cool thing now is that I can actually reuse the debugger. So when I say now, because now the context has the debugger, I can say context debugger send, and I can send it some data. And now there's one format of data which is displayed in a specific way, and that format is method, which is dispatch, and then I can give it a color, for example green, and then I can give it some args, and this could be like the arguments from, does this work, args, yeah, okay. So now I have a dispatcher which doesn't do anything, but we want to tell the debugger that we are doing something. So if function B here dispatches, for example, add to do, and I don't know, payload is title foo, for example. Okay, let's see what happens now. We test it. And when function B now ran, it actually told us it was dispatching add to do, and it way over here it says the title foo. This is of course a graphical bug, but the thing is that this is just so awesome. Like, if you need to do these complex state changes, you can just install functiontree and grab a provider related to whatever you're doing, Redux or like I mentioned, MongoDB and whatever, and those should be implemented with the debugger in mind. So we can kind of like have this amazing generic debugger that helps you understand the flow of practically everything. And what we can also do here is change this to be like a node debugger provider. So when you are doing stuff on Node, we can rather debug it like to the terminal and give it some nice colors and stuff. But I think this is pretty awesome. So the question now is how to handle parallel and all that stuff, because like now it works the same way as in Cerebral, only that since you don't like put an async property on things, it will allow you to run parallel with both async and synchronous. So for example here I could do func A, which is asynchronous, it returns a promise, and I could do func B, and that will actually work. Function tree doesn't care about that. Like, putting this array in here just means run all these functions. Don't wait for the first one to finish, just run all of them. So it doesn't really matter if it's async or synchronous. But the thing is when you start composing, so if you have like other tree here, let's say you put that here, and that other tree has func A and func B. Now, when you run this tree, it will first run func A and func B. First run func A, and when it's done, it will run func B. But if you compose it into this other chain, suddenly we get this. And now it will actually run func A and func B immediately, which is not what you intended maybe. So you have to remember to use the spread operator. And the debugger will help you notice these things, but it isn't like optimal. It would be really nice if there was some parallel stuff going on here, but yeah, we haven't quite decided on that yet. So because then we have to implement like an extra export, and it would be really nice if all these flows could be just objects, arrays, spread operators, and yeah, just complete native things to JavaScript. Anyways, so I hope you got a bit excited about this. I'm super excited. So I will be showing off more as I keep hacking on this. Bye bye.